Today we're going to be looking at the binary number system, and the key with the binary number system, we are used to using a base 10 number system, right? We've got, usually we think of it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we're used to, and that's what we think of. But this number here is pretty distinct, right? It's 2. It's got 2 places instead of 1. So that's right off the bat an indicator that we have something different going on in terms of what we should look at. And what we really should look at is 0 through 9, right? That's what's significant. These are all single numbers. 0 gives us, obviously, the idea of nothing. If we look at a base 2 number system, what would that look like? Well, if we have 10 values here before we start moving on to new places, what would a base 2 look like? Well, imagine instead of those 10 fingers you have to count on, you just have 1, and it can either be up or down, then you have to move on. So let's go ahead and get that. And again, to review, I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then now what? Well, I take something that tells me I have 1 in the new places, and I go 10. And that's why we call it a base 10 number system, because it's really just 10 to the 0, which is 1, and then 10 to the 1, which is 10, and then 10 to the 2, which is way over here, 100, and then we have 10 to the 3, which of course is 1,000, and so on. Right? That adds all those places. But in a 2-number system, all we have is 1 and 0. So how the heck does that work? Well, if I were going to write a binary number, the first thing I would want to look at is this is a base 2 number system, so let's look at our values. Well, 2 to the 0, just like anything, is always 1. 2 to the 1 is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. And 2 to the sixth is 64, and hopefully you've got the idea, right? So when we write binary, we always write 1, 0, 1, 1, 0, 1, 0, 1, 1, 1. So, whatever. But how do we make an actual number out of that? Well, if you want to make the number 0, then that one's pretty easy. If you want to make the number 1, then that's pretty easy. But what if I want to make the number 2? Well, I only have 2 symbols to work with. I have 0 and I have 1. So once I run out of symbols, just like with my other number system, I have to move over. So in order to write 2, I write 0 because it's either 1 or 0 there, and then I write 1 because I now am in the 2's place. So this is the 1's place, this is the 2's place, and then remember this base 10, so this is the 4's place, which is going to seem weird to our brains that are used to base 10, right? Then you have the 8's and the 16's and the 32 and the 64 and the 128 and the 256. And if you've been paying attention to anything going on with your computer, you're probably going to recognize those numbers. So what this is if I have 0 1's and 1 2, then my number is 2, and this is my decimal version, right? But let's write another number. Let's think about what this looks like. So now I'm going to write the number 7. So let's do our binary places out here, and this is a good little exercise. So how many 1's do I have? How many 2's do I have? How many 4's do I have? How many 8's? How many 16's? I'm sure I have enough to make 7 now, but how would I do it? Well, if I look at all these numbers, I'm not going to need 16, so I wouldn't even need to write that 0 out there, but I could. And I'm probably not going to need 8 since that's bigger than the number I'm going for. But what I do need now are all of these numbers. So my binary number might look something like this, or just 1, 1, 1. But what about a bigger number? Well, let's do 23. We'll do a nice prime number there. So again, I'm going to use my little help here. How many 1's, how many 2's, how many 4's, how many 8s, how many 16s, how many 32s. And again, once we get to 32, we know we've gone too far. So we've got to add the rest of these numbers up somehow to make 23. So starting backwards, if we start with 16, we're probably going to need that. But what plus 16 is going to make 23? Well, 16 plus 8 gives us 24, so we don't need that. But what about the rest of these? I'm going to need to make up for the difference between 23 and 16, which is 7. And it just so happens all those make 7. So there's my binary number with a 0 right in there. And that is the number 23 in binary. And hopefully by now you're starting to catch on a bit. And let me know if you have any questions.